And welcome back once again. In this video we are going to have a look at how we can save some information about our object before we start loading it. And to be able to save something, we will need to have an understanding of something called PlayerPrefs in Unity. And PlayerPrefs is something that we can use to store variable data between game sessions. So if you use some of these PlayerPrefs to store some data, well, then the data will also be there next time you load the game and you load these variables, so you can actually save something and load it later in the game or in another game session. So let's have a look at what a PlayerPrefs is. To access the PlayerPrefs, you'll just have to write PlayerPrefs, and the PlayerPrefs has some different static functions on it. And if you want to save something, you write set, and then you can see there's three data types you can save. You can save a float, an integer, and a string. So let's just try to save an integer. And when you do this, it asks for a key, and this is the label that you would like to save this value under, so that you can get it later. So if we call this label h, let's say we want to store an h in our game, and make a comma, well, then after here we have the value we want to store under h. Let's say this person is 30 years old, for example. And that's it. Now you stored the value 30 under the label h. So later in your game, when you want to load this, you can simply just say int h equals PlayerPrefs h. So now this h variable here, not PlayerPrefs, but get integer, of course. Get is for loading something and set is for saving it. Then I say int h equals PlayerPrefs get integer h. So h here is going to be equal to 30. I can try to save this. I don't want to put this in save, of course. I would like to put this in load, for example. But now we would set h and we would load it down here, and that's what we are going to do with our with all our objects and all the values that our objects are going to store. For test purposes, we can just do this in the start function here. And if we save this, and if we say debug.log h. So let's try to test this by going back in Unity and running the game. And if I open up the console, you'll see that it wrote 33 times here. So it did it for every single one, but it saved and loaded it for every single one of our objects. And that's how the PlayerPrefs works. So we will need to make a structure so that we can use this for saving some important information about our objects. So let's try to set up the save function inside our save game manager here. In the save function, we will have to call save on every single object in our savable objects. And to do that, we can use a loop to run through the savable objects list. So we can make a for loop. And the reason that I'm using a for loop instead of a for each loop is because if we look at the savable object, the save function here, it needs an ID, and the for each loop runs from 0 to the max amount of objects. So the ID here is going to come from the integer in the for loop. And the length here is simply going to be saveable objects dot count. There we go. So now it's going to run the same amount of times as we have objects in our savable objects list. And in here we say savable objects, and we can access the list with the index here, and I is going to be increased at all times. So we are going to say savable objects I dot save, and the save function needs an ID, and that's simply I. So now we call the save function on every single object, and we provide it with an ID here. So the ID is based on the position in the savable objects list here. So that's a save function, but we haven't added anything to the savable object yet. So we'll have to go to savable objects, and in here in the save function, we will have to add some specific information for each object that we want to save. So first of all, it's the name of the object or the ID we would need to save. So let's simply just make use the ID here as the key that we want to store the object under. So we can actually say PlayerPrefs dot set string. And the reason that we're using a string is because we can convert everything to strings. We can convert our vectors for positioning and for scaling to a string, and we can convert like anything else, like the object type and everything, for a string. If we used integer, then we wouldn't be able to convert lots of things into this way of storing it. So set string, and the key is basically the ID, and then we need to store a string value. The first thing we would like to store is simply just the position. So let's just try with the position first and then build it up slowly. So we want to store the transform.position to string, and that's basically it. And here it complains about the ID because it's an integer, so we need to say ID to string as well. Now that we can save the position, we can set up some functionality for loading it. And to do that, we will have to call the load function on every single object. But we will also have to do that in the game manager before we actually do it inside the savable object, just as we did before with the save. So let's jump to the save game manager. And in here, we'll have to add one more thing to the save function, because when we load our objects, we will need to know how many objects we saved so that we can load the correct amount of objects. And to do that, we can make a PlayerPrefs inside save dot set integer. We can call this one object count, and let's give this the savable objects dot count. So now we know how many objects we save. So when we click the save button, it's going to save the count of objects in the list currently. So the next thing we'll have to do is to make sure that we load all these objects. And we can do that by loading the amount of objects first. Int integer called object count equals PlayerPrefs dot get integer object count. And the object count is the one we saved up here, so we can simply just write it like this. So now this object count here is going to be equal to the amount of objects we just called save on before. Then we'll have to make a for loop, because we need to instantiate all these objects, and we can just use the object count in the for loop here. Yes, okay. So the next thing we'll have to do is to load these objects. And that means that we need to call the load function on our object. And to do that, we can make a string, and we can call this value, and it's equal to the save, what's we called PlayerPrefs. That's what I want to say. That get string, and we used the ID before when we were the I as an ID before when we were saving the objects, and we can do the exact same thing when we're loading them. So use I to string, of course. So now this value here is going to be equal to a position in our game. We can try to save this and put a breakpoint here. And if I attach to Unity and I go back in here and run the game. Oh wait, of course we need to call load first. So let's try to make two buttons actually, just for saving and loading. So go to UI, click button, and rename this one to save, and expand it and select the text. And here you can also say save. And then you can just duplicate it and rename this one to load, and click on the text and rename this to load. And then just move the two buttons a little up so we can see them on the screen. There we go. So now we have two buttons for saving and loading. Let's just put them here about the middle. Yes, so the save button will need to call the save function on our save game manager. So if you click on a button, you'll see that there's something called an on-click event down here. And to use the on-click event, you'll simply click the plus, take the save game manager, drag it all the way here, and then you can select the function on the save game manager by selecting no function, save game manager, and select the save button. And you do the exact same thing for the load. Click on the load button, click on the plus, take the save game manager, click on the function, save game manager, and load. So now we can load and save our game. You know what, instead of attaching it, I would actually like to do something else. If we move the debug, let's just say go into the game, into Visual Studio or your Mono developer, write debug.log value. Now you'll see that it's going to write out the values of each of them. If we go back here and run the game now, and we click the save button, and we click the load button, then you'll see that we have 3 values here, which are the positions of all objects. So now we have actually just saved and loaded the position for all our objects. Now that we can save and load the position, we can start adding the functionality for instantiating the objects in our game. So to do this, we'll have to create a new folder in our asset folder, and it's very important you name this folder correctly, because if you don't, then it's not going to load them correctly when you export your game. The folder we're going to create is called the resources folder, and this folder is compiled with the game, and everything in it we'll be able to reach everything in it from our game when we export our game to a standalone game, for example. So if we right click on the asset folder, click create, and click folder, we will have to write resources. This folder will contain a prefab for every single object we can instantiate or load in our game. Instead of making a prefab for each sprite here, you could also make one prefab and then just save the sprite with the position and everything, and then load the sprite when you inside your load function to get less prefabs if it's not needed for you to have more prefabs. But in this case, I'm just showing you an example of how it works when you have more prefabs than one. So let's try to take our mushroom and drag it into the resource folder. Do the same for our crate. And we will have to do the exact same thing for our stone. So now we have these 3 objects in here. So now that we have them, we can go back to our save and load script. So as I told you, we are going to do this step by step. So we will just load one object now, and then we'll move on to be able to distinguish between the different objects, right? So first of all, we will have to make a game object and call it TMP, and it's equal to instantiate resources. Let's see if I can find it. Resources dot load, and in here inside the apostrophe game object, inside the quotation marks here, quotations, we will have to write the name of the prefab to load. Right now we can't distinguish between the prefabs, so you'll just have to pick one of them you just created. So I have the crate, for example. Let's just create the crate. So we write crate and save. So now it's going to create a crate for us if we did everything correctly. So let's try to save and jump into Unity and play the game. And we already saved before, so we don't need to save, but we need to have an eye open here in the hierarchy to see if there is going to be 3 extra crates now when we press load. And we clicked load, and now we have 3 crates, as you can see here. But they are all placed on the exact same spot as our normal crate, as you can see here. And we need to make sure that we use the values that we just loaded, and we pass them on to our crate here so that we set the position. So we have to jump back into the script. And in here we'll have to access the savable object script on the temporary object and call the load function and give it the value. So we have to say temporary dot get component saveable object dot load, because we need to call the load function on each of these objects here we create. We call the load function, and as you can see, it wants an array of values, a string array of values. So basically we don't have a string array right now, so we can say values to we we can only say char array, so let's just simply say let's just actually quickly change the values. Let's just put values in here, and instead of converting stuff around to an array right now, we will simply go to our savable object and change the load function to not take in an array at the moment. We will change it back in a few minutes, but let's just change it around. There we go. So if you went to the specific object and remove the brackets here after load, and remove the brackets after load on the savable object as well, both the specific and savable, well, then you should be able to give in the value here without any errors. And the reason we are using a normal string instead of an array right now is because we're not saving more than one value, but we're going to change it back to an array soon. Now we call the load function, and inside the savable object we'll have to set up some things so that we can actually set the position. So basically we will have to say transform dot local position equals values. But here's a problem. Values is a string, and the local position here is a vector 3. So we'll have to translate our values into a vector 3 before we can actually set the position of the game object in our game. So we have to go to our save game manager, and in here there was a function called string to vector, and we'll have to create that function correctly so that we can actually load our position. So how do we do this? We can say value equals value dot trim. So first of all, if we get a vector, this is just an example, we get something that looks like this: 1, 23, 3, for example. So this is what we get from the value string. We will have to remove these brackets here to be able to translate it into a vector with x, y, and the z values here. So to remove the brackets, first of all, we will have to say trim, and trim can take in a char array that can decide which characters we would like to remove. So we say new char array here, and then we open up the scope here, the brackets, and inside the brackets here we need to tell it which kind of characters to remove. We want to remove the first bracket here, and then make a comma, and we also want to tell it that it needs to remove the second bracket. There we go. So this means that the characters now looks like this: 1.23.3. But I think there is some white space like this between them. It actually looks like this for real, like this. So there's like maybe some spaces here between the commas, and these white spaces are also going to interfere with our conversion. So next thing we need to do is to say value equals value.replace, and inside replace we replace a space with a not space, without a space. So now when we're done with this line of code, it actually looks like this. Okay, so the next thing we need to do is to create an array so we can extract 1, 23, and 3, so we have them alone without the commas here in between. We do that by saying string position equals value dot split, and split splits these things up based on a character. So we say split comma. So now it's going to split these up, which means we are going to end up with an array that has position 0, which is equal to 1, position 1 is equal to 23, and position, maybe I should move these commas because they're not going to be there, and position 2 is going to be equal to 3. So we're going to end up with this, to have 0 is 1, 1 is 23, and 2 is 3. And now we can actually return the correct vector. So instead of returning vector 3.0, we can return this vector, return new vector 3, renderer, nope, return new vector 3. And we can say float.parse. So we need to convert this string. This is still a string array, right? And we need to convert it into a float because x, y, and z are floats in a vector. So we have to say position 0 as x, float.parse 1. If I can hit my keyboard here. Float.parse 1 and float. I'm kind of sleepy apparently. It's position 1 and float.parse position 2. There we go. Okay, so now we have a vector based on what we just saved. So this returns the correct vector because we just made this conversion from a string that looks like this to a vector that looks like this down here. Okay, so that was the string to vector conversion. So now we go back to the specific object and not specific, sorry, loadable, savable object, and we say that we want to say game manager, not game manager, it's called savable, save game manager dot instance dot string to vector, and we're just going to give it the string here called values. There we go. So now we should be able to set the position on all these objects. So let's try to save and jump back to Unity, and we should run the game and we load. Then you'll see the boxes has now been placed on the correct positions in our game. I know it's not a mushroom and a stone wherever they were, but we can place stuff, we can load, we can save stuff and place it at the correct positions. I am going to end this video here. In the next video we will start loading the correct objects, and we'll also have a look at how we can remove the old objects, because right now when I'm loading, the old object still persists. If I move this one, we also still have the stones. Of course we need to delete the old objects, so we replace them with their new with their loaded version. And yeah, what else? We are also going to save some more things like rotation, size, and we're also going to save the values like strength and health, I think, whatever we had of properties on our specific object. Thank you very much for watching, and don't forget to subscribe if you haven't done it, and follow my Twitter page and like my Facebook page. And again, remember that InScope Studios is a community founded page, so all help, all support from you guys is very, very appreciated. You can support me just by writing a comment saying thanks, sharing my videos, or simply supporting me on the Patreon page. If you support me on Patreon, you will get some different perks, for example, all my projects, and you can also get private tutoring and help for your own projects. If you don't want to support me with that much on the Patreon, you can also just go to the link on the screen right here and download this project or any of my other projects. Thank you very much for watching.